So, hi everyone. Hello, and welcome everyone to today's virtual event by Tech Thrusters. So, as usual, we are here with another virtual event brought up for you. And I know it's Sunday evening and everyone must be done with their weekend and all. So, I hope this informative session would be enjoyable for everyone and something informative because we're coming up with a new hot topic today. We have an amazing speaker for that. And yeah, so today it's going to be about LLMs and something interesting. A person who has worked on LLMs and really from the basics to everything in detail. So he has some kind of different perspectives of various security approaches and how it can be built with that approach. So I would like to welcome Abhijeet. So
Hello, thanks for the
hi
intro, Raghav.
Abhijeet. Yeah,
Hello.
so Abhijit is a security researcher who has been in cybersecurity from around 2 years, and he has done some great work in web APIs, networks, and he's doing some great work in AI as well. So he has been working on LLM models, building them from using different kind of APIs and even though securing them with proper AppSec perspective. So not taking much time, I would let Abhijit handle the stage because it's gonna be a great informative session. I know definitely you guys are gonna enjoy it. So feel free to enjoy the session, take notes, and we are gonna store the session into YouTube. So that's fine if you wanna check it out later as well. So let's go start the session and handing over to you, Abhijit.
Yeah, sure. Thanks for the intro, Raghav. So, hello everyone. Today we are going to talk about LLMs and basically integrating them into your applications with a security first approach. So, a little intro about me. So, I have around 2 years of experience in security. My physical experience involved developing security tools and automation processes. In my previous role, I had the privilege to work on LLMs, and into this, I implemented LLMs with a security-first approach. I also have a hands-on experience in security pen testing and have been actively involved into the bug bounty space. I am also a speaker. I have spoken at various conferences and even sharing my security insights and overall journey. So on the screen, you can see the socials below. So if you want to connect with me, collaborate, or discuss on any security related topic, feel free to ping me anytime. So this is our agenda for today's session. We will, have a little bit intro about LLMs, what exactly they are, how do they work, then LLM integration approaches, like how organizations basically integrate LLMs into their existing, applications. What are the multiple ways by which LLM can be placed? Then we'll see common security challenges. We'll first have an implementation method, a diagram as a case study, and one-on-one we'll see security challenges for each components, which are commonly seen in wild. Then we'll see famous LLM vulnerabilities that have happened in the past. These are the CVs which were popular. Then we'll see how to test our security of the LLMs using various open source tools. And in general, we'll discuss about best practices to keep in mind while integrating LLMs in your applications. So let's start. So nowadays you can see LLM is being in the talk in the industry. It's like a super hyped up market right now. You can see the statistics. This is the market study done by Springs. The global LLM market is set to, in 2030 to be around $259.8 million, which is huge. And by 2025, an estimated 750 million applications will use LLMs. And these stats are, to be honest, true to a certain extent because nowadays you see each and every company wants to be a part of this AI hype. They want to integrate LLMs, AI in any sort of use case into their applications, or offer it to customers maybe, or for the internal users. LLMs can also help to streamline internal processes as well. So the adoption of LLM has being, widely accepted by organizations of any industry, not just that other industry as well have adopted this. And it has been a really hot topic recently in the market. And you now and then see LLM related news like new models launching, new approaches launching, and this has been a talk. But there's also a side about security. Every now and then news articles like this, show up on your feed. And we really wonder, like, is security as which is placed in traditional web application perspective is being implemented in LLMs? Like these repetitive issues are occurring at large scale organizations, and this has huge impact because LLMs need to be taken super seriously. If you have any LLM, attached to certain tools or features, not just used for chat, but it can do tasks for you, then you basically have a huge risk of getting compromised. You can see here most of this involve, exploitation, access to your internal system, or maybe leaking confidential files, which can be a huge compliance risk as well. So security needs to be, in the frontier while you are adopting LLM patients. So let's start with some basics. So what exactly is LLM? In Wikipedia, you'll get this all big, definition, and I'll not go too much into the technical side of this, but in simpler terms, large language model can understand and generate human-like text. So this basically allows a seamless integration into applications because based on the inputs or any queries, whatever the users are giving, LLMs can, answer accordingly, reason accordingly, and give you certain perspective or guide you into a way where you want, right? So this is what LLM does, and how, and this is some basic token by token prediction, like how LLMs complete the sentence once you give output. So suppose you have some input, and then LLM, what it does is it takes the first word and then has a probability distribution of many tokens or words, like which of the next token matches with the previous one, and then the one which has maximum probability in the distribution that is appended to the sentence, and this occurs each and every iteration. So one by one, token by token, the sentence gets completes, and you can see as the next token heavily depends on the previous token, so even small changes in the input can shift these probabilities, leading to completely different outputs. So that's important to keep in mind because this leads to the next slide, which is non-deterministic nature. Since LLMs are, uh, do not have a fixed pattern of output regarding to a certain input. These by default are non-deterministic in nature. Slight variations in prompts, how you craft the prompt, how you ask the LLM to do a certain task. This can, heavily impact your responses. And many a times, even the same worded prompt as it is does not give the same response every time. And this, this non-deterministic nature of not having a fixed pattern of output makes placing security controls like difficult in LLM applications because in traditional applications, what you have, if you were generating certain output, you can, match flags or match strings, which can detect malicious outputs. But in case of LLM, the static checks do not, apply, and security is really difficult to replace in LLMs. So, given with the basics, now let's move on to how organizations really adopt LLMs. So, if you are, working in organizations or building your own projects, there has been this question many a times, like, where should I start? Should I train and, create my own LLM? Should I use open source models from Hugging Face, which are free of cost? Hugging Face provides you models, LLM, large language models, embedding models, data sets free of cost. These are open source. Then whether to go with API providers because it has minimal setup. You just, get the API and start working. So let's see one by one these LLM integration approaches, what exactly they are, and then later we'll move on to security issues specific to some of this integration approaches. So first one is building and training your own model. So organizations basically, when they want to create their own LLM specified to their use case, whatever it might be, they can go with this approach. So it's like creating your own LLM into your infrastructure. So LLMs maybe this can be trained on the dataset which the organization has created, or if it has some generic use case, datasets can be, we can get datasets from open source providers, but training LLMs to your own data set and into your local environment needs massive compute power. And the organizations which are ready to afford this, mostly go with this approach, because for normal users, this is basically not an ideal case, because the requirement of massive compute power is a big question. Then why do organizations go with this approach? Better security and compliance is the main reason, because since everything is under your control, you have the complete control on how security should be placed on the LLM model. You don't need to rely on some other another vendor or something. And if your LLM once deployed, right, uh, processes customer data, client data, so that's a sensitive data, and you don't need to risk giving it to some third party. Since it's in your own environment, there will be not a compliance issue. So basically, that's why organizations go with this. The next one is the open source models. So our favorite platform, Hugging Face, like it provides the LLMs, embedding models, data sets, and this has more control over deployment. Like LLMs are ready to be used. You just, download them and deploy in your local network or a cloud, personal cloud. So it's pretty straightforward to use. Also, if you have, once the LLM which you are downloading from the open source providers is being trained on generic data, but you also want to fine tune it on your own documents, this can be done pretty easily. You don't need to, go for the pre-training method. The pre-training is already done. Just fine tuning for your use cases is more feasible. Also, cost is a big factor. These are, available at little to no cost. In most of the cases, they are completely free. And if you are a startup or a individual who wants to just explore this, does not have that financial barrier to use the LLMs, and it's pretty easy. No vendor locking. This is the most crucial aspect, because in many organizations, once you get services or products from a vendor, now, after your entire process is streamlined, later on switching to another vendor might be costly, and like it can cause issues. Now, this vendor lock-in, there's no requirement like as an issue here, because by using open source models, you just download whatever you might feel that this will fit my use case. You test it, and if you don't like it, you just discard it and download another model. So this makes it pretty easy to test and run. You don't have to go through a large set of processes. So that's why most of the individuals or organizations, basically startups, go for open source models. Then API-based LLM providers are one of the most popular ways to integrate LLM in your application. Yeah, like most of the popular names like OpenAI, Grok use this. They provide LLM API-based LLMs. So these are really ready to use APIs. You just get the API key. Then these service providers itself have their documentations, by referring to which you can easily start developing on things. And you don't need to mostly focus on the back end of these models, because the that's entirely the provider's responsibility to keep, to improve them, to update them regularly, to have security patches, and all this performance aspects is maintained by the provider. Also, users based pricing, this is basically pay as you go model, basically token based payment process, or the number of API calls which you make, you only have to pay for that. And since these big companies, are day by day striving hard to, release latest tech and better performing model, you don't have to invest on hefty R&D. You just pay for what you use, and that's it. This is one of the most feasible. solutions, like ideal, I would say that organizations use API-based LLM providers. So after you have decided the approach, right, like what I'll do, and organizations just heavily focus on performance testing applications, like whether they give proper output for a certain input, they are matching the use case, etc., etc. But no one's really testing for security, right? Because this is completely a new space, and people don't know like what should I check for security. It just gives me text back. I don't see a problem in that. And basically, whenever organizations say this, they basically miss out the fact that these LLMs can cause a huge trouble to their organizations. And as the quote goes here, if you only test for performance, you are not integrating an LLM, you're integrating a liability. Because in future, in some days, like whenever if there is a security issue, some hacker finds it and it exploits it, your organization is going to pay for the loss. Like there can be financial loss, legal repercussions, and this is something you don't want to happen with your organization. So it's pretty important to test for security as well whenever you are doing performance testing. So by just evaluating performance isn't enough. Like let's say the security impact. Uh, Once an LLM can be exploited successfully, whether it is connected to some tools, you attackers can get into your internal infra, any all sort of this, scenarios are there. This can impact financially, customer trust and reputation damage because if customer is using a chatbot and he's getting like hallucinated response, not up to the mark, and even reputation damage since your bot is speaking, uh, ill about some competitor. So this can be a use this for the reputation. Market value and business impact, whenever there is a security incident, the market value for that company obviously crashes. So this is something that needs to keep in mind whenever you are integrating some new sort of tech. Here in this case is LLM. Legal and compliance risk, this is one of the most crucial, which needs to be, seen because if your LLM is leaking any confidential data or user PII, personal identifiable information, this can cause you legal issues and also compliance risk. So it is really important that your LLM should be, strong. It should not succumb to the security attacks. So where do this risk basically originate from in your opinion? So first one is LLM implementation method. Like risk can vary based on whether your model is in-house, open source, or API based. There are different risks for how your LLM has been implemented. Also, if you control your LLM with other applications, it can also cause a use risk because even though your LLM is secure, but your other tools and features are not, then that makes the whole component unsecure. So that's something that needs to be looked into. Tools connected to LM, we just now discussed. Inference and output risk. So often as the training data, is so large and it's based on real world, there are biases. There can be hallucinations based on this vast information. And therefore, this is a huge risk. And also in output, sometimes if there are sensitive information, it is also a risk. Model deployment and access control. Access control needs to be placed because in some scenarios, organizations have LLMs, which can be used by multiple hierarchy level people. And nowadays LLM also has options for uploading documents, uploading some things you have so that you can process with it. And suppose there's an access control failure, and a low level hierarchy employee can access the documents which high level hierarchy employee using. So this can be an issue, right? And then user input handling. So very famous prompt injection attack, system prompt leakage attack. This is something that needs to be kept in mind. So OWASP, which stands for Open Web Application Security Project, has an extensive list of top LLM vulnerabilities. You can go to their official site and get the document. It has beautifully, explained all these vulnerabilities, how it can be mitigated, different attack scenarios. This will give you an overall understanding of what you need to keep in mind while integrating LLMs. So while developing it, Once you have these vulnerabilities in picture, you know whether this implementation method or this feature will cause any of these issues. You can fix it on the go. So let's see this implementation method. This is basically a RAG implementation, retrieval augmented generation. So I'll explain to you what it is. So here's your user. He gives a prompt. Okay. So, and then you have a set of documents which are internal to your organization. Now, with embedding models and vector DB, these data is converted into a numerical representation into high dimensional space. So this is basically done so you can get semantically similar, uh, data chunked into different clusters. So once you have the prompt given by the user, you can retrieve relevant information whatever is matching to the prompt and send it to as a context to the LLM. So LLM has proper context with the question and the internal data. Also sometimes developers what they do, they have a prompt, then they perform a web search and they get 5 or 10 most relevant results and also send them back with the context. So in this scenario we have a prompt, we have this RAG workflow, which has data, internal organization data, and even the resources from the web. And once these are sent, LLM gives the response back to the user. So now let's focus on this component, LLM. Now we'll go component wise and see what all issues can appear in this. So for this LLM, now suppose you go for training an in-house model, right? Your LLM is an in-house model. So what you should keep in mind. So basically, data poisoning is the major concern for training in-house models. So this basically occurs when you are pre-training data, fine-tuning data, and this can introduce vulnerabilities, backdoors, biases. You can, uh, since you are relying on some data source to train your model, and you have not properly evaluated that data, there's a high chance you can poison your data since multiple biases, hallucination can be caused for the LLM. So what are the risks? So see, as someone I have seen that people whoever are with the fine tuning or pre-training LLMs blindly, download data from all the open source providers, whether some, there are lots of data sets available on the internet. And since the data sets are large, it is, people avoid to check what exactly the data contains. And publicly available data sets may contain biased, misleading, or malicious data because most of the data sources nowadays social media. And like these data sets contain that chat, maybe comments, or any blogs or forums which are not actually validated. If you see the recent blunder, like Google integrated the Reddit's data into it, and you can see how the AI bot was performing, right? It was not good at all. So this can heavily affect. So and this poison data basically lead to hallucinations, misinformation, or unethical responses. There can be regional bias, then regional biases, gender biases in your output, and this is something you don't want. Also, another part, while pre-training, people scrape data, like there are crawlers, scrapers, which just, pull out as much as data which is possible. And you don't know if sometimes an hacker might have, wrote a forum or blog and in the source code, it has some prompt injection payloads. Like when this model gets trained and once, even if you are using it in RAG, like if it gets embedded in your LLM application, your LLM application might not behave as it needs to be. Next one is the open source model. Like if you go for the open source model, like ready available model from Hugging Face Baby. So what are they lying with this? Pickling vulnerabilities. So this is one of the common part, and not just with LLMs, with traditional ML models as well. This vulnerability has been seen like from a long time. So open source LLMs or any models are distributed in serialized files, .pickle or maybe other output format. So what it does is like once you have created a model, you send it into a pickle file, and once any user downloads that. He just loads it and starts running it. But no one really checks if that pickle file has, some malicious code into it, or maybe that model internally is doing some malicious activity. And once some user, loads it, and then maybe he might be compromised. And this is something you need to keep in place. I personally will suggest that whenever you have any LLM models or any traditional ML models, make sure to run it into a sandboxed environment. That should not be directly run on your server or any other system which has, other functionalities as well. If compromised, can disrupt your entire service. So safe serialization methods like tensors should be used and run models in isolated environments, sandbox environments. This is a must. Then unverified training data and copyright risk. These open source models, like you basically sometimes don't know how these models are pre-trained, right? Where the data originates from. And most of the time, these data can be through copyrighted books, articles, or any other materials. And if they are trained on later on in your usage, the LM spits out the same information. Oh, this can be a huge copyright risk for you, for your organization. Even suppose this is trained on some personally identified information, and LLM model just spits out the information in the output. You can get compliance issues like and legal repercussions. So this is something you need to keep in mind. Always integrate from trusted resources. So let's come with third-party API providers. Now, since third-party API providers are one of the most, feasible solutions to be used, they have a risk, which is data privacy and exposure, since you are giving it to a third party. Suppose your LLM processes client's data. You are using client's data to, help client make decisions on the data or perform some activities. Since these are going to third party, you need to keep in mind that this should not cause any compliance issues because some regulations strictly prohibit sharing customer data to third-party clients. So this should be third-party providers. So this should be kept in mind. Then is API abuse and over dependency. Attacker just needs your API key. If by some way this is leaked and an attacker gets hold over it, so uh, basically you will get a hefty amount of bill because attacker is also using your API for his own personal. So API needs to be very protected. And later, there is over dependency on these API providers, like we have seen in the past. Whenever ChatGPT goes down, most of the AI startups go out of service, and this gives out pure hint that many of these startups are using this third-party API providers. So there needs to be like limited dependency. Don't over depend your entire product on some third-party LLMs, because if that third party crashes, your entire product will fail, and that is a huge loss for your business as well. So these are some general LLM risks. So if you are training data and your training data set includes PII, then as usual, as is the nature of LLMs, it might split information about it. If you have an in-house LLM model and it has the documents you are sharing with the LLM has information about internal structures or employee details, so or maybe your trade secrets, so that can be leaked, and it can cause a huge issue. Access control issues, like as I said, multiple hierarchy level employees. If there is access control issues, the features which you provide for higher hierarchy, lower hierarchy, that can be abused. Even sometimes, since continuous training can be incurred in some LLMs, so maybe chats can go across different users, and this is something you need to keep in mind because access controls need to be placed if you want to, segregate your different users in your organization if they are using it. So since we have covered the LLM component, let's go to this RAG component. So if you a simple basic about this is whenever you have in-house data or some documents which are unique to your organization and you need them to give context to your LLM. So these are you stored in vector DB, and it's a high level dimensional thing where data is converted into numbers, and these are, placed in it. And this can be used for semantic search and, getting relevant document chunks for your prompt, whichever the matches. And this is also something that needs to be secure because OS has also listed some vulnerabilities into this. So this is vector and embedding weakness, unauthorized access, and data leakage. As I said, see, if your RAG, see, not training, training is something like LLM is being pre-trained, but RAG is on the spot context, right? So if your RAG approach has some documents which have sensitive information about your organization, and LLMs are directly including it, there's no filter for PII or something, then attacker might know this sensitive information. So first it needs to be clear that whatever data you are providing to the LLM should not contain any personal or sensitive data that might harm your organization. And plus, if whether there's a huge data, right, sometimes it's difficult to pick out each and every sensitive information, so you can, grab a filter or a guardrail in the output method so that these data is not passed on to the user. Then there's embedding inversion attacks. So basically, as there are encoded embeddings, right? These can be engineered, and whatever is present in the RAG, these embeddings, whatever is the human readable text, that can be retrieved back by the attacker. So this is keep in mind. So do not include any sensitive information, even if it is engineered. It should, if it is not sensitive information, you don't have anything to be worried about. Then there is cross-context information leak and federation knowledge conflict. So in multi-tenant environments, right, you have multiple user classes. So there's a single application or a service running, and multiple user classes are using that application. And if suppose you have a shared vector database, so it might happen that a query of one user might result into a vector store retrieval of a context of another user. So this can be a big issue. And what's a federation knowledge conflict? Suppose your LLM is being trained on certain data, pre-trained, okay, and this data is being outdated, and your RAG workflow has latest data. Now, since your LLM is pre-trained on outdated data and your RAG is also providing a context with the recent data, in certain cases there might be a possibility that LLM not behaves in a required response, and this is the federation knowledge conflict. Next, let's come to the user. So, what a user can do, if, like what how security should be kept in mind while you are looking at the user component. So, the most famous vulnerability, prompt injection. This needs to be addressed because this is one of the most common uh, vulnerability in LLMs. So a prompt injection is basically whenever a user prompts something, right? And it tries to, make the LLM do something that is not in its defined behavior. That is prompt injection. And this can be, be in many forms. Like one of this is the direct prompt injection. Like if you're typing anything into the input box and, crafting a well prompt that bypasses some defined rules of the LLM, that's a prompt injection. And the second one is the indirect prompt injection. So this can come into the web as if you have a workflow that is retrieving some information from the websites. Now, attackers can craft some prompt injection payloads into their blogs or even the source code that is not visible while you're reading a blog, right? And once LLM starts parsing through this content, like it sees the prompt injection payload and behaves differently. This can cause an issue. So this is what indirect prompt injection is. And you need to filter what user is giving and also what you are including from websites, external websites. So you can place guardrails. We'll cover that part later on, but guardrails need to be placed so that you don't, are not vulnerable with this vulnerability. Now, whenever LLMs are connected with some tools, the security impact increases dramatically. Like if your LLM has, you know, ability to search the web or to do any activities on the web, if it has the ability to run code on your system, or it has the ability to, change settings or configurations about your system. So this is something like it is crucial. Like if you are implementing some this LLM with tools kind of architecture, this needs to be very secure. Like if things go south, like you'll have, you'll be at a huge loss, you and your organization. So that needs to be kept in mind. So with this, let's see excessive agency. So what exactly is excessive agency? So whenever your AI system or LLM has, too much autonomy, like it performs certain actions without, approval. It has this freedom to perform, like executing code, retrieving data, updating data, making decisions on the fly on its own. Like it's connected to these tools. It is just getting the user query and making decisions. So and it has too much flexibility. This is excessive agency, and root causes basically are excessive functionality. Like you have given LLM too much functionality that needs not to be in the first place. Second, excessive permissions. You are running LLMs into high privileged user as a high privileged user. So if someone exploits your LLM, he directly has control as an high privileged user on your system. Excessive autonomy. Like if a prompt injection vulnerability has occurred and AI has been asked to carry out certain malicious actions, if there is no user validation placed in between, this can cause a huge security impact. So these are some examples that are listed on the OWASP official document. So excessive functionality, excessive permissions, excessive autonomy. Like maybe you have databases, you have functionality that do not need, merging databases, creating a new database. That's not required. That there's, database administrator for that, but you have given it. So if exploited, this is an issue for excessive functionality. Excessive permissions. If your AI chatbot needs only, is required only to retrieve data, but it also has to update, to delete data, the data columns in itself. That's excessive permission right then. And excessive autonomy. Suppose you have some as your document deletion feature. This something see whenever there is creation or deletion. This is something if it is not in a critical environment or on a critical system, then do not automate this using LLM without a user in picture, because this can cause dramatic side effects, and it will be a huge loss for the security. So keep this in mind. So let's see popular vulnerabilities that are there, like that have been seen previously in. So first one is CV 2024-5565. So prompt injection enables RC in Vona AI. So Vona AI was an application which had the functionality like a user in natural language gives a prompt, and accordingly, as the instructions are, the Vona AI crafts the SQL query and performs it on the database. So this was what initially they planned, but like as the functionality was there, there was an ask method where you can input your request, and if there was a visualization feature as well, like your entire prompt process and how the visualization is going, that was visible. And once it was set to true, so this query used to go into that, and then a set of instructions were run on the system, and that was run by the Python exec command. So what these researchers did, they crafted such a payload, like they injected some prompt injection methods. Like there was like in every instruction append or add this Python command. So what this LLM did, for every instruction added that Python command, and once it was entered into the Python exec function, that exec function ran those commands on the system. And since these were not sandbox environment, it directly was running on the system, and so this was full blown RC, remote code execution. So this was the attack flow. So if you have similar implementations in place, like there are certain preventive measures that you need to keep in mind. So strictly input, there need to be input validation and sanitization. Like Don't pass on any malicious code from the user, like never. Check for that, because if you have some code execution feature into your LLM, this can cause a huge risk. And but it is always better whenever you are running an LLM, run it in sandbox environment, because even though it is compromised, attacker can do nothing. Okay, because it is a sandbox environment and you are completely safe. So keep this in mind. Always use sandbox environment. Next vulnerability was CV 2024-34359. This is the Llama drama. So server-side template injection caused remote code execution. Let's see how this worked. So we have a Llama CPP Python library. So this is a library used to, integrate AI with Python binding for the llama.cpp. So this was used to load and run Llama models. And what it did was, while loading it, read the model metadata. So if you have some chat template, like in the official POC, you'll see there's a chat template, and researchers included an SSTF payload into this. And since this was not, running in the sandbox environment, the Jinja 2 template engine rendered this SSTR payload, and this caused an RCE. So you can see that if similarly you are implementing something, again, input validation is must, like even in traditional vulnerabilities like SQL injection, cross-site scripting, input validation was crucial. And even in LLMs, input validation is one of the most important things. And please, 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 whenever you run LLM or you are executing anything, please execute in a sandbox environment, and in a proper sandbox environment that it cannot be escaped also. Okay, so this is very crucial. And also source verification, whenever you are loading any models or any packages, any engines, always check if it is from a trusted source, it does not has any, you know uh, security vulnerability into it, because directly this will impact your organization. So we talked about guardrails, like I mentioned guardrails a few times. What exactly are guardrails? So this can be any logic package or another LLM, which can be used to as a filtering mechanism, as during the input process and output process from the LLM. If any input process contains any PI of the user, if suppose by default I as a user I am inserting my API key. Sometimes developers, what they do, they just copy paste code into ChatGPT and they forget to remove API keys or other eh, confidential details. Or else I am entering my PII if I am trying to do off-topic conversations, like if some AI uh, is only discussing about history, and I am trying to, get it do something else for me. This is off topic. And if there are certain jailbreak attempts, if I am trying to, write a malicious code, so this are the input guard, which can be used to avoid this. And what are output guard? Suppose your LLM is hallucinating, or your LLM gave a profanity output, like it has bad words into it, or even if it has biases into it, this can be removed. Even sometimes computer mention can be there, this can be removed. Like anything that's coming out from the LLM which you do not want to be shown to the user, output guard can be used. So for guardrails, there are many the tools and implementation ways which you can look online. You can create your in-house implementation. You can just create a rule-based logic for this. You can use another LLM for this to evaluate what is the input, what is the output, and accordingly pass it on back to the user. And also you can use available tools. There's guardrails.ai. I guess Labs also provides a guardrail, so you can use that. So how guardrails basically help us? So prevention of harmful outputs, anything that is profanity, misinformation, biased content can be stopped. Data privacy and compliance, if your output is leaking any PII, or if the user is giving any PII, like both of this can be stopped using the guardrail. Brand safety and reputation. So if there is competitor mention or there is some trade secrets, like any internal information about your organization, this can be, uh, by using guardrail, not allowed to go back to the user. If there are jailbreak attempts, if someone is using automated security tools to, jailbreak a LLM, guardrails can help you identify that. As I previously mentioned, content moderation is also one of the things. Fact checking and reducing hallucinations. So this can be done as well. Basically, for this use case, another LLM will be a good fit into this, and user trust and experience will be increased because since your user is, getting safe responses, accurate, contextually appropriate. So obviously, your user trust and experience will be enhanced. So if while you are developing, see, as we mentioned, various approaches, right? As security needs to be taken into consideration right from the start of the integration phase. After you have integrated everything, after it's complete in your dev environment, you can start testing. So these are some security testing tools. Garak is one of my favorite tools. This is provided by NVIDIA itself. So this is a vulnerability scanner. It has, bunch of checks you can use like prompt injection, jailbreaking, profanity check. So Garak is my regular go-to tool. And this is also said as this Garak is Nmap for LLMs. So this is one of the tool you definitely need to check out. Then there's Rebuff, which is self-hardening prompt injection detector. There's Plexiglass, glass, there's Vigil LLM, there's Jailbreak Evaluation. And these are all open source tools, so you can use them freely. There are also other providers who do security testing for LLMs if your organization has budget for security. So you can obviously go for those services as well. So these are the best practices that you should keep in mind while integrating LLMs. Always use trusted models. Like always verify the source, always verify that it does not have any, vulnerabilities or security risk. And so that if it being integrated into our application, uh, like does not need to cause any security impact. Then there's apply strong access controls. Access controls need to be placed like who can access some features of your LLM. And LLM can be, differentiated between different access controls. Always sanitize inputs and outputs. So you can do rule-based checks or guardrails or use any other LLM for this. Assess all connected tools and integrations. So not only just test the LLM, whichever you are using, test for all the tools and integrations you have done with the LLM. So sometimes your LLM is completely secure, but the tool has some traditional vulnerabilities that makes the entire component unsecure. So always test the entire system, whichever that is connected to the LLM. Monitor and log interactions. Always monitor everything because this can, if something happens, you can always go back into your logs and check what went wrong. And also, logging can help you if you are, continuously training your model. These logs can help you to train your model based on previous feedbacks and, improve by each iteration. Isolate LLM components, like use sandbox environments, isolated containers, so that even they are compromised, they don't spread out the impact to other components. Implement guardrails. Guardrails are a must if you have your LLMs into production. Like this will definitely help you, avoid many of the security issues, and periodically test for vulnerabilities. Like if you have a penetration testing team, or if you by yourself use some open source tools and or get surveys from other company which does this for you. Regularly, I say quarterly test for vulnerabilities. Like this is very crucial. You will get to know like what is your entire security posture over your implementation and deployment phase. So that was all about integrating LLMs. Thank you so much. And if you have any doubts, you can connect with me on LinkedIn. So feel free to reach out to me. And I'd like to thank Tech Thrusters for this. Thanks to Weber for having me here. So it was really fun, like sharing my research with you all.
Thank you so much, Abhi. Really,
Yeah.
like it was a one of the great sessions over LLM ever attended. So I would say it was really thorough. You have literally included everything that was supposed to be considered while considering the security approach and that perspective towards the LLM and AI integrations. And nowadays, literally everyone wants to integrate APIs
Yeah.
from different LLM models, open API, and like so they don't even check for such facts. And I literally love the two, three examples that you have given about the data sets, right? So
Yeah,
people don't consider the verifying of like whether the source of database is genuine or not. So that
yeah.
is also, yeah, that can cause a lot of issue. Just I just got it now. So yeah, thank you so much. It was really a great session, and thank you everyone for being consistently over here. And I hope you got something new to learn today. And see you in the next event. Thank you for joining on a such a late night. I would say late evening in the weekend mostly. So it's Sunday and you have showed up. So thanks a lot for that. See you in the next one. Thank you guys. Thank you everyone. Thank you Abhijit. And
Thank you, Vibhu.
have a
Bye.
good, yeah. Bye. Bye
Yeah.
everyone.